picture this. You are sitting on your couch at the end of a long day, just looking down at your phone.
Oh, yeah. We have all been there.
Right. And you have like 3 unread text threads that you've been ignoring since Tuesday.
Mm.
There's a group chat that somehow accumulated 47 new messages while you were in like a single meeting.
It's exhausting.
It really is. You have direct messages waiting on Instagram, an email from a college friend you haven't seen in 3 years, and suddenly you just feel this heavy, creeping sense of guilt.
Yeah, that social burnout.
Exactly.
Yeah.
You want to be a good friend, you want to keep in touch, but the sheer volume of people you are supposed to maintain a connection with just feels completely overwhelming.
And totally paralyzing.
Well, if you have ever felt that specific type of burnout, welcome. You are not a bad person. You are just fighting against the biological limits of your own brain.
Which is a very real, very modern tension, honestly.
Yeah.
I mean, we are living in an era of infinite connectivity, but we are trying to navigate it with hardware that hasn't fundamentally changed in millennia.
And that tension is exactly what we're digging into today. Welcome back to another deep dive.
Glad to be here.
We have a really fascinating stack of sources to go through today, pulling from anthropological research, neurobiology papers, and even mathematical sociology studies.
It is a great mix of data.
It really is, and all of these center around a concept you might have heard of, which is Dunbar's number.
Right.
Our mission today is to figure out exactly why your brain puts a hard cap on your social circle, how this impacts your romantic life, and, whether modern science actually still believes this rule holds up.
It's a lot of ground to cover.
It is. Okay, let's unpack this. We aren't just talking about a philosophical limit on how many friends you have, right?
No, not at all.
We are talking about literal physical real estate inside your skull.
Yeah, we are looking at the biological imperative behind those limits.
Yeah.
Because it's incredibly easy to view friendship as just an abstract emotional concept.
Sure, like hanging out, having a good time.
Right, sharing interests. But from an evolutionary standpoint, maintaining a relationship is intensely resource-heavy work for your brain.
Wow, really?
Yeah, it requires continuous metabolic energy and actual physical neural infrastructure.
Okay, so I think to understand that infrastructure, we have to start with the mystery of why our brains got so massive in the first place.
Absolutely.
Because for a long time, the assumption was that human beings evolved these huge brains to, build complex tools or discover fire.
Or solve abstract problems, right?
Exactly. But looking at the von der Heide research from 2014, the leading idea is actually something called the social brain hypothesis, which argues that primate brains basically blew up in size to handle the sheer drama of living in groups.
Drama is a good word for it. The cognitive load of social interaction is just staggering when you really break it down.
How so?
Well, to maintain a stable relationship with just one person, your brain has to build and constantly update a behavioral model of them.
Oh, like tracking their personality.
No, exactly. You have to remember past interactions, track favors you owe, favors owed to you.
Right.
You have to navigate potential conflicts and understand the dynamic between that friend and, other people in your wider group.
That is a lot of data.
It is. And doing that for dozens of people simultaneously requires immense processing power.
Which brings us to the famous number itself. Back in 1992, the anthropologist Robin Dunbar was looking at this exact dynamic in primates, right?
It was, yeah.
And he noticed a direct correlation between the size of a primate's neocortex, that's the outer layer of the brain handling higher-order functions, and the size of the social group that specific primate species lived in.
Right. It's scaled up together.
Exactly. So when he took that correlation and mapped it onto the size of the human neocortex, the math spot out a very specific limit.
Roughly 150 stable social relationships.
Right. 150, any more than that, and the theory suggests our cognitive resources just kind of snap.
And what gives that 1992 theory so much modern weight is the physical evidence we are now finding inside the human head.
You mean the neurobiology stuff?
Exactly. The von der Heide study reveals a direct correlation between the size of a person's active social network and the physical density of their gray matter.
Wow.
Specifically in regions linked to social cognition, like the amygdala.
Okay, I want to make sure I'm fully grasping the mechanics here. When we say denser gray matter, we are talking about more physical synapses, right?
Yes,
Like more actual pathways built to handle this emotional profiling.
that is exactly what it means.
So if I try to maintain an active network of, say, 200 people, my brain is essentially acting like a smartphone's RAM.
Oh, that's a good way to put it.
Right. It only has so much short-term memory to keep apps running in the background. So if I force 200 heavy apps to run all at once,
The battery drains faster.
exactly, things start to stutter and eventually the system crashes. So is gray matter density essentially our biological hard drive space for friendship?
That analogy holds up incredibly well, actually. Friendship is not passive storage. It is an active background application.
Right.
Every time you interact with someone, your brain is firing up those pathways. It's cross-referencing past behaviors, predicting future reactions.
Just constantly crunching the numbers.
Yeah, and if you don't have the biological RAM, the gray matter density to support that active processing, the connections inevitably degrade.
So that's why you, forget a birthday.
Exactly. You forget a birthday, you lose track of a major life event they told you about, and the relationship naturally slides out of your active network.
Okay, but the way we process people isn't uniform, right? I mean, I obviously don't treat the barista I see every morning the same way I treat my absolute best friend.
No, of course not.
They don't require the same amount of background processing power.
Right, and that nuance is where the internal architecture of Dunbar's number becomes so crucial. It is not a flat list of 150 equals.
Okay.
It is a highly structured ecosystem. There's research from Akarji and Paniker, published in 2023, that maps out how this network is organized into concentric circles.
Like a target.
Basically, the hierarchy is based on trust, emotional closeness, and the frequency of interaction.
Right, the tiers. I remember reading about this. At the very center of this ecosystem, you have your inner circle of about 5 people.
Your core.
Yeah, the closest support group. The people you call when your life is completely falling apart. Then outside of that, the research identifies a layer of about 15 people known as the sympathy group.
Right.
These are the close friends whose death would genuinely devastate you. Then it expands to 50, which are the standard friends you might invite to, like a large group dinner.
Yeah, exactly.
And finally, the outer boundary of 150.
And managing those different layers requires drastically different levels of cognitive investment.
I bet.
The inner circle of 5 requires near constant updates and intense emotional processing. The outer layer of 150 requires much less frequent interaction.
You still know who they are, but it's easier.
Right, you know how they fit into the broader social picture, so the cognitive load is lighter? However, the Acharji and Paniker study highlights something deeply counterintuitive about how these networks actually hold together at that outer edge.
Oh, right.
They found that in order to expand your network outward toward that 150 mark, the required levels of trust among the individuals actually have to increase.
Yeah, okay, wait. Here's where it gets really interesting. Because I was reading that part of the study and struggling to wrap my head around it.
It throws a lot of people off.
Right, because my instinct is that my closest 5 friends require the absolute highest level of trust, while the outer layer of 150 casual acquaintances requires the least.
It seems logical.
Yeah, if I barely see those outer 100 people, why does the trust requirement suddenly need to go up just to keep them in the network?
Well, if we connect this to the bigger picture, the distinction here is between interpersonal trust and systemic trust.
Okay, unpack that for me.
Interpersonal one-on-one trust is definitely highest at the center with your core 5.
Yeah.
You trust them with your secrets and your safety.
Right, I trust my best friend completely.
Yes. But when Acharji and Paniker discuss expanding the network, they are talking about systemic group cohesion.
Ah, systemic. Okay, I think I see the mechanism there. If I have a tiny group of 5 people, I don't need a complex system of rules because I can just, physically monitor everyone.
Precisely.
We are always together. I know if someone isn't pulling their weight, but if the group expands to 150, I can't keep an eye on what person number 142 is doing when I'm not around.
You can't.
So I have to rely on a broader assumption that everyone is playing by the same social rules.
That is the exact mechanism. You are relying on shared norms, reputation tracking, and perhaps social gossip to keep free riders in check.
Gossip as a survival tool. I love that.
It is. The baseline level of systemic trust required to keep a massive group from fracturing into smaller, competing factions is incredibly high.
Because it's structurally fragile.
Exactly. Expanding your network introduces structural fragility. So to counteract that fragility, the overall systemic trust within the group has to scale up.
Wow.
It's just a brilliant look at how heavily our brains rely on invisible social contracts just to maintain the outer boundaries of our world.
It really paints a picture of this delicate, perfectly balanced biological budget.
It really does.
We only have so much bandwidth, and it's meticulously distributed across these circles. Which leads to a really fun question.
Okay.
What happens to this finely tuned ecosystem when a massive disruptive shock hits the system? Something like, falling head over heels in love.
That is perhaps one of the most mathematically ruthless aspects of this entire framework.
It really is. The Acharji and Oza research from 2024 dives straight into this.
Yes, the cost of romance.
Right. They analyze the stability of social networks when individuals enter into new romantic partnerships. And because our social bandwidth is a rigidly capped, zero-sum game, bringing a new, intense romantic relationship into your life forces an immediate mathematical shift.
You don't magically grow more brain capacity.
No, you don't. To accommodate a new partner, you basically have to evict someone else to make room.
And the specific cost they identified is fascinating. The research shows that when an individual enters a new, stable romantic relationship, they typically lose 2 people from their innermost support network.
2 whole people.
Yeah, that core layer of 5 shrinks to accommodate the new partner. 2 people are pushed out to the outer rings to make cognitive and emotional space.
It's the classic disappearing friend phenomenon, mathematically validated.
It really is.
Your friend starts dating someone new, and suddenly they just drop off the map for 6 months.
Yep.
It feels a bit like a corporate hostile takeover.
A hostile takeover.
Yeah, think about it. You have this board of directors in your brain, your core 5. This new romantic partner comes in, and they don't just want one seat on the board.
Oh, I see where you're going.
They need a majority stake. They essentially force a buyout of 2 of your best friends' shares to secure their position and monopolize your emotional bandwidth.
That is quite the analogy. But while the hostile takeover idea implies malicious intent, the biological reality is completely pragmatic.
Right, it's just biology.
The new partner requires a staggering amount of cognitive processing in those early stages. You are learning their habits, predicting their emotional states.
Integrating their social network with yours.
Exactly, building deep bonding pathways. The brain simply cannot maintain the previous level of intense investment in those 2 displaced friends while doing all that new computational work.
So it's purely a resource allocation issue. It is not a personal slight against those friends.
Entirely. It is a mathematical necessity of the brain. Emotional bandwidth is the currency, and the new relationship demands a massive influx of capital.
Okay, so if our biological hard drive is the strapped for space, to the point that falling in love mathematically costs us 2 close friends, how do we explain the modern digital world?
The digital illusion.
Right, because if you're listening to this right now, you might have like 1,500 followers on Instagram.
Or 800 friends on Facebook.
Yeah, 500 connections on LinkedIn. We effortlessly interact with thousands of people every day. Doesn't that shatter the 150 limit?
It creates an illusion of scale, certainly. But when you look at the data, the digital world does not rewrite our biology. It simply exploits different cognitive mechanisms.
Yeah, the von der Heide study touched on this, but the West et al. Research from 2020 focused specifically on online social networks, right?
Yes, they did.
And they found that even on massive digital platforms, our cognitive limits remain stubbornly fixed. You can follow thousands of accounts, but the number of individuals a person maintains in an active social circle online still averages right around 150.
Active being the key word there.
Right, meaning people you consistently engage with, message directly, track emotionally.
The West et al. Study is particularly compelling because it bridges sociology and psychology through mathematics.
How did they do that?
They evaluated the flow of information across human social networks and found that the efficiency of exchanging meaningful data peaks right around that 150 mark.
Really?
Yeah, regardless of whether the network is physical or digital.
Wow. So what does this all mean for the influencers or the hyper-connected networkers?
Sure.
If they interact with thousands of people online, are they just creating an illusion of intimacy? Or are they literally skimming the surface of their gray matter? Are they stretching their inner circle of 5 into a paper-thin circle of 5,000?
What's fascinating here is the distinction between passive consumption and active social maintenance.
Okay.
An influencer broadcasting to 1 million people is engaging in a one-to-many broadcast. It requires virtually no individualized cognitive processing.
Even when they reply to comments.
Even then, replying to hundreds of comments is a fleeting, surface-level interaction. It doesn't require the influencer to remember the commenter's emotional history or map their social connections.
They aren't navigating mutual obligations.
Exactly. Digital platforms make it incredibly easy to passively consume the lives of others. Scrolling past a photo takes a fraction of a second.
And requires zero emotional updating.
Right. But they haven't fundamentally altered the evolutionary constraints required for active relationship building. You cannot hack the physical limits of your amygdala with an algorithm.
Wow. So the followers are just data on a screen. They aren't actually running as background apps in the RAM.
Exactly.
It makes total sense. But, as clean and mathematically satisfying as this 150 rule has seemed throughout these studies, we have to look at the current scientific debate.
We do.
Because modern science is actively throwing some major punches at Dunbar's theory.
It would be a massive disservice to present Dunbar's number as an undisputed law of physics. It is fiercely debated right now in modern evolutionary biology and anthropology.
Yeah, the pushback is led by research like the 2021 study from Lindenfers, Wortel, and Lin.
Yes.
They essentially set out to deconstruct the entire concept. They used vastly larger data sets than Dunbar had access to back in 1992.
They did, and they applied modern phylogenetic methods.
Okay, to clarify those methods, phylogenetics basically looks at the complex evolutionary family tree of species, right?
Exactly.
The Lindenfers team recognized that primate brain evolution isn't just a simple straight ladder leading directly to humans.
Right, it's messy.
Very messy. Different primate species evolved different brain structures to survive in vastly different environments. So drawing a clean, straight mathematical line from monkey group sizes to human group sizes based purely on neocortex volume.
A bit of a leap.
It is a highly controversial statistical leap.
And the data they produced by looking at that broader evolutionary tree is wild. When they recalculated the cognitive limits on human group sizes, they didn't find a tight cluster around 150.
No, they didn't.
They found a massive 95% confidence interval, which, for anyone not deep into statistics, basically means they are 95% sure the true biological average falls somewhere within this range.
And do you remember what that range was?
It went from as few as 2 people to over 500 people.
A range of 2 to 500 is so wide that it essentially renders a single average number meaningless for practical application.
Lindenfers and his team concluded that attempting to specify one strict cognitive limit on human relationships might be completely futile.
So if the scientifically proven range can stretch all the way to 500, isn't the rule of 150 just a catchy average that completely ignores how different you and I are?
That is a very valid point.
I mean, it feels like we might be trying to force a really messy, diverse human reality into a neat biological box. If an introvert genuinely maxes out their cognitive load at 15 people, and a highly social extrovert has a biological capacity for 400, calling the human limit 150 feels like it erases human diversity entirely.
That is a vital critique, and the Lindenfers study provides the data to back it up. We should absolutely not view 150 as a magical threshold where your brain suddenly short-circuits.
Right.
Environmental factors, cultural differences, and profound individual neurological variations play massive roles here.
However,
There's a however.
yes, if we step back and synthesize both sides of this debate, the underlying principle of the original theory remains incredibly robust. Meaning, even if the specific number is flawed, the reality of the limit isn't.
Precisely the point. Whether your personal limit is 40 or 400, you still have a limit.
Yeah.
Your social bandwidth remains a finite biological resource. You still operate within those concentric circles of trust. You still pay a cognitive cost for romance.
And your brain is still not infinite.
Exactly. The biology of exhaustion is very real, even if the math is fuzzy.
That reframing is crucial. The specific number might be up for debate, but the mechanism of burnout isn't. Which brings us to what you can actually do with all this anthropological and neurological data.
The primary application here revolves around self-compassion, really,
Yeah.
and setting realistic expectations for your own life. First, stop spreading yourself so incredibly thin. Accept that you only have the cognitive resources to deeply nurture a handful of relationships.
It's okay to let go a bit.
Yes. Release the guilt of not being able to maintain deep connections with all 1,500 of your social media followers, or even all 50 of your casual acquaintances. Focus your limited biological RAM on the inner circles that actually sustain you.
I love that. And second, give the people in your life some grace when it comes to the romance cost.
Oh, absolutely.
When your best friend disappears for 3 months because they started dating someone new, it is not a betrayal. It is literally a biological necessity.
Their brain is reallocating gray matter resources to process a massive new emotional input.
Right, so let the hostile takeover happen, wait for the dust to settle, and just know that eventually the board of directors will reorganize itself once the cognitive load of that new relationship lightens up.
There is one final thread to pull on here, actually,
Oh.
and it's something I want to leave lingering for everyone listening today. We established that active social network size directly correlates with the physical density of gray matter in the amygdala.
Right, the biological hard drive.
Yes. We also know that we are increasingly spending our lives interacting in massive, superficial digital networks that constantly push against these evolutionary boundaries.
Instantly.
We are spending hours every day trying to force thousands of passive connections into a neural infrastructure built for a few dozen active ones.
That raises a really intense question about where we go from here.
It does. Because if the physical structure of the brain adapts to the environmental demands placed upon it over long periods of time,
Oh, wow.
could our modern digital habits eventually cause an evolutionary shift in the physical structure of our brains? Generations from now, will the human amygdala look fundamentally different because we spent centuries trying to trick our biology into being friends with the entire internet?
Are we evolving our hardware in real time just by scrolling?
It's a real possibility.
That is a thought that is going to stick with me. Well, that is all the time we have. Thank you for spending some of your limited cognitive bandwidth to join our circle today.
Thanks for having me.
The next time you look down at your phone and see that terrifying wall of unread messages, don't panic. Just remember, your brain is a biological hard drive, and it's completely okay if you only have enough RAM to text your Core 5 back today. Thanks for joining us on this deep dive, and we'll catch you on the next one.